Now, the remaining parts of the first chapter, units and measurements, physical laws of conservation. The first law is law of conservation of energy. You have learned this law in the 7th or 8th class. Energy can neither be created nor destroyed, but it can only be transformed from one form to another form. Again, energy can neither be created nor destroyed. It can only be transformed from one form to another form. Suppose a ball is placed at a certain height A at rest. Then at this point, kinetic energy is 0 and the potential energy is mgh. Now, after falling this distance h, it comes to this point. Before striking this point, what is the value of the potential energy? That is equal to 0. But its kinetic energy will be equal to, as you can calculate, is mgh. That means the total energy remains constant. That is equal to mgh. Here kinetic energy is 0, potential energy is mgh. At this point, all the potential energy is converted into the kinetic energy, but there some remains constant. So this is the law of conservation of energy. Now the second law is law of conservation of linear momentum. Law of conservation of linear momentum. You know the linear momentum in your 9th class. P is equal to mv. In short, I am writing here, if no external force acts on a system, that means F is equal to 0. No external force acts on the system, the total linear momentum of the system remains conserved. That means P is equal to constant. The condition is that F is equal to 0. Another form you can also say, for an isolated system, if no force acts on the system is said to be then isolated system. The total linear momentum of the system remains constant. Now the third part is law of conservation of angular momentum. Angular momentum, this term is new for you, angular momentum. Just as for the translational motion, such that for the translational motion force is required, similarly for the rotational motion torque, for the translational motion force is required, similarly for the angular motion torque is required. Whenever the force is there, objects move in a straight line or a translational path. Whenever there is rotational motion, we have to apply the torque. The object moves in a curved path. Now, in the same way, we can define it here. Only the difference is that instead of force, here is torque. Instead of linear momentum, here is the angular momentum. If no torque act on the system, torque is denoted by this symbol. This is torque, the symbol of torque. If tau is equal to 0, means if no external torque acts on the system, the total linear momentum of the system remains conserved. In other words, you can also say that for an isolated system, whenever we say an isolated system, that means no torque act on the system. The total linear momentum of the system is conserved. And the last one is law of conservation of charge. 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 Now, how can you state this one? In the 10th class, you have learnt that when a glass rod is rubbed with silk cloth, this is your silk cloth, this is your glass rod, then glass rod becomes positively charged and the silk cloth becomes negatively charged. Why this becomes positively charged? Because it has a tendency to lose an electron. It becomes negatively charged because it has the tendency to gain the electron. The object which gains the electrons becomes negatively charged and the object which loses an electron becomes negatively charged. Now before rubbing, there is no charge on glass rod, and this is your object 1 A, this is the objects B. The charge on A is 0 and these two objects are not rubbed with each other. So before rubbing, what happens? Before rubbing, you can say here net charge is equal to 0 because charge on the glass rod is equal to 0 and charge on the silk cloth is 0. After rubbing, you can say that it becomes positively charged, it becomes negatively charged. How much electron it loses? The same number of electron it gains. Therefore, both the objects have equal and opposite charge. Net charge is Q plus minus Q. This becomes equal to 0. Before rubbing, net charge is equal to 0. After rubbing, charge is equal to 0. This is due to law of conservation of charge. How can define this law? The charge can neither be created nor destroyed, but it can be transferred from one body to another. Again, charge can neither be created nor destroyed. It can be transferred from one body to another. This is your physical laws of conservation. The first law is law of conservation of energy. The second law is law of conservation of linear momentum. And the third law is law of conservation of angular momentum. And the last one is law of conservation of charge. Now, any physical quantity, how can you express any physical quantity? For representing physical quantity, there should be its magnitude as well as its unit. That means any physical quantity, I have written the physical quantity in this form Q. Q means physical quantity. Its numerical value, it is represented by N, and its unit I have represented by U. Suppose the length of a pole is 2 meter. How meter? 2 meter. Then 2 is its numerical value and unit is meter. You can convert one unit into another unit. Then their numerical value also changed. How much if we write this one in centimeter? Then numerical value becomes, 1 meter is equal to 100 centimeter. That is equal to, in 2 meter, you can write it here 200 centimeter. This is your N1, this is your U1, this is N2, this is U2. Product of these two are the same, but their numerical values as well as their units differ from each other. Smaller is the unit, more is its numerical value. Larger is the unit, then the less will be its numerical value, so that their product remains constant. In 2 units form, you can write this expression such one, N1 U1 is equal to N2 U2. This is the general formula which should be noted. Any physical quantity can be expressed as the product of its numerical value and the unit. If you convert one unit into another unit, its numerical value also changes. That means in general we can write this formula as such, N1 U1 is equal to N2 U2. This is your numerical value. Now there are so different types of unit, but What do you mean by the standard unit? What should be the qualities, yeah, you can say characteristics of an standard unit? Characteristics of a standard unit means that unit which is accepted word wise. Why the value of the 1 kilogram is the same word wise? Why 1 meter is same word wise? There are certain restrictions. That is why we can say that unit is a standard unit. Number one, it should be of the suitable size. Suitable size means it should not be too small, too large. ठीक ठाक होना चाहिए, ना बहुत बड़ा होना चाहिए ना बहुत छोटा होना चाहिए. नंबर टू, इट शुड बी डिफाइंड एक्यूरेटली. उसका एक डेफिनेशन होना चाहिए. डिफाइंड एक्यूरेटली. 1 kg है तो 1 kg इतना ही है. नंबर थर्ड, easily reproducible means that we converted from one unit to another unit. Number fourth, does not vary with time. That means the value remains same, does not vary with time. Next one is does not change with physical condition. With physical conditions. That means physical conditions में टेम्परेचर है, आपका डेंसिटी है, उसके अनुसार ये चेंज नहीं होने चाहिए. आपका 1 मीटर है, पता चला आप आज 1 मीटर है, कल वो 1.5 हो गया, ऐसा नहीं होना चाहिए. 1 मीटर है तो जिस मटेरियल का वो हमेशा 1 मीटर ही रहेगा. गर्मियों में बढ़ेगा नहीं, जाड़ों में वो कॉन्ट्रैक्ट नहीं होगा. चेंजिंग फिजिकल कंडीशंस में प्रेशर ज़्यादा हो गया, टेम्परेचर हो गया, तो उसकी लेंथ क्या हो गई, इंक्रीज हो गई. ऐसा नहीं होना चाहिए. जितना साइज है उसका उतना ही रहना चाहिए, ऐसे मटेरियल का होना चाहिए. तो दीज आर द करेक्टरिस्टिक्स ऑफ द स्टैंडर्ड यूनिट्स. फर्स्ट ऑफ ऑल सुटेबल साइज, ना साइज ना बहुत बड़ा होना चाहिए ना बहुत छोटा होना चाहिए. डिफाइंड एक्यूरेटली, एक पर्टिकुलर डेफिनेशन दैट बी एक्सेप्टेड वर्ड वाइज, इजीली रिप्रोड्यूसिबल मीन्स फ्रॉम वन यूनिट टू अनदर यूनिट, डज नॉट वेरी विथ टाइम, डज नॉट चेंज विथ चेंजिंग with physical condition, with changing physical condition. That means गर्मियों में, जाड़ों में वो चेंज नहीं होना चाहिए. These are the characteristics of a standard unit. Now in our syllabus there are standard unit, SI system of it means SI system of unit, SI system of unit, international system of unit. System of unit. It is accepted word wise. So it is based on some fundamental units and 2 supplementary units. There are 7 fundamental units. Fundamental units. Number 1, mass. And mass, the unit of the mass is kilogram. In symbolic form we can write as here kg. K should be small. Number 2, length, and length that means meter, is symbol is small m. Number 3, time that is represented in second and the symbolic there is s. Number 4, temperature, it is represented in SI unit Kelvin. This is here capital K. Number 5, electric current, and its unit is in 9th class also, ampere. It is represented by capital A. Number 6, luminous intensity, it is represented by candela. Its symbol is Cd. And the number 7 is quantity of matter. It is represented in symbolic form as mole. Now I am repeating again. These are the 7 fundamental units. All other units can be derived from these units. Number 1, mass. This is your physical quantity, and this is your symbolic forms of the unit. Mass, kilogram, in symbolic form kg. Length in meter, in symbolic form small m. Time, second, in symbolic form small s. Temperature, Kelvin, capital K. Electric current, ampere, capital A. Luminous intensity, CD, this is known as candela. Quantity of matter, mole, MOLE, in symbolic form it is represented as mole. Now there are the two supplementary units. Supplementary units, there are only two supplementary units. Supplementary units. Supplementary units. Number 1, this unit is, you know, number 1 is plane angle, and it is represented in radian. Number 2, solid angle, it is represented in steradian, it is SR. These are the supplementary units and these are the fundamental units. Your SI system is based on 7 fundamental units and 2 supplementary units. All these definitions are given. You have to learn these definitions. How can you define 1 kg, how you can define 1 meter, and so on. Now, what are the advantages of SI system of units? Why SI system of unit is accepted worldwide? Advantages of SI system of units. SI system of units. SI system of units. System of units. So what are these advantages? Number 1, it is coherent system of unit. Coherent system of unit. What do you mean coherent system of units? That means this SI system is based on some fundamental units and the units of all other physical quantity can be determined from that fundamental units. Number 2, rational system of unit. Rational system of units. System of units. This system assigns only one unit to a particular physical quantity. Suppose energy, electrical energy, magnetic energy, potential energy, any types of energy, kinetic energy. The SI unit of all types of energy is joule. Whether it may be electric energy, magnetic energy, kinetic energy, potential energy. Because all these are energy, SI system assigns only one unit to that particular physical quantity. That's why it is a rational system of unit. Number 3, it is the absolute system of unit. Absolute system of unit. Absolute system of unit. Absolute system of unit. That means there is no gravitational factor G. The factor G is not included in this SI unit. Therefore, that is no, because the value of G varies. That's why it is also known as the absolute system of unit. Number 4, this is metric system of unit. Metric system of unit. That means you can say all the multiples and submultiples can be expressed in the power of the 10. Suppose meter. Meter is your SI unit of the length. Now, how can you convert meter into kilometer? Then you know 1 kilometer is equal to 10 raised to the power 3 meter. And how or you can also say 1 meter is equal to 10 raised to the power minus 3 kilometer. 1 meter is equal to 10 की power 2 centimeter. All the multiples and submultiples can be expressed only in the powers of 10. That's why it is known as the metric system of unit. Once again, what are the advantages of SI system of units? It is a coherent system of units. That means the SI system of unit is based on certain fundamental units, and the units of all other physical quantities can be obtained by using these fundamental units. Number two, it is a rational system of units. That means it assigns only one unit to a particular physical quantity. If whatever may be the name of the energy, the SI unit is the same, that means joule. Absolute system of units, that means the factor G is not present here. It is free from the factor G. Number fourth, metric system of unit, all the multiples and some multiples can be expressed in the power of 10, which you can see from here. So that is the end of the advantages of SI system of unit. Now the most important topic of this chapter is dimensional analysis, which is very important, and the question comes from this topics. Now your dimensional analysis. Dimension analysis. Dimensional analysis. This one is the name of the subtopic. Now, you know the fundamental units. Mass is represented by here capital M, and it is placed within the square bracket. Length is represented by capital L. Length is represented by capital L. It is also placed in the square bracket. Time is represented by capital T, and it is represented in square bracket. Only we are using three fundamental quantities: mass, length, and time. It is always represented by the capital letters, and these letters should be enclosed within the square bracket. Now, what is the dimensions of distance? So distance, you know, distance means length. Distance, what is this dimensions? Distance means हो गया का length हो गया. That means L. Now it is only L. M and T are absent. We can write it here, m raised to the power 0. You know, m raised to the power 0, that is equal to 1. L t raised to the power 0. Then what are the dimensions of the distance? Dimensions of the distance: in mass is 0, in length is 1, in time is 0. So these powers are known as the dimensions. Now, from this one you can determine the value of the speed. How can you determine speed, dimension of the speed? Now, speed you can write here, distance divided by time. Distance divided by time. Now, what is the dimension of distance? That is, you know, L. And what is the dimension of time? That is, you know, T. You can write in this way here, L T raised to the power minus 1. Now, m is not present here, so in the proper form we can write it here, m raised to the power 0, L t raised to the power minus 1. Then what are the dimensions of speed? Dimension of speed: in mass is 0, in length is 1, in time is minus 1, and this is known as the dimensional formula. Now, you can determine the dimension of all other physical quantity also. Now, what is the dimension of acceleration? Acceleration. How can you determine the dimension of acceleration? You know, acceleration is equal to change in velocity divided by time interval. Now, what is the change in velocity? You know, displacement divided by time. That means L t raised to the power minus 1. Time interval, that means time, that is their time. Now, after simplifying it, we get L t raised to the power minus 2. And in proper form, you can write it here, m raised to the power 0, L t to the power minus 2. This is the dimensional formula of acceleration. Now, as you know the dimensional formula of acceleration, what about force? Force is equal to mass into acceleration. Mass into acceleration. And what is the dimensional formula of mass? Capital M. What is the formula of acceleration? L t raised to the power minus 2. What is the dimensional formula of force? M L t raised to the power minus 2. You have to learn it, not from the formula. You must know the formula, substitute its value, you can get its value also. Now you can determine the work done. Work done is equal to force into distance. Distance, yeah, displacement you can say. What is the dimensional formula of force? That is equal to m L t raised to the power minus 2. What is the distance? It is expressed in length L. Now by simplifying this, we get m L raised to the power 2 t to the power minus 2. Similarly, you can determine the dimensional formula of other physical quantity also.